Okay, so question 7 says a biased coin is tossed 3 times. The probability of a head from a toss of the coin is P. Find in terms of P the probability of obtaining 3 heads from 3 tosses. So we can identify this as a binomial distribution, where we either have success or fail. So success is a heads for this question, and a fail would be a tails. So for the binomial distribution, our probability of whatever we're looking for is the same as however many trials we've got, choosing however many successes we want, by the probability of a success, which we generally call P, to the power of, R, and then 1 minus P, the probability of a failure, for the power of N minus R. So if we had 10 trials and we wanted 5 successes and 5 failures, we'd have 10 choose 5, and we'd have P5, 1 minus P to the 5. Alright, so back to our actual question though. We have that our probability of heads is just equal to, alright, so we're going to choose 3 from 3. Oops, there's no fraction sign in there. So that's a combination. 3 from 3, doing badly now, times P to the power of 3 times 1 minus P to the 0. And if we clean this up, that's the same as 1 P cubed times 1. Anything to the power of 0 is 1, so we just get P cubed as the answer. You might have also thought as that just being the probability of a head times the probability of a head times the probability of a head equals P to the 3. But technically it's a binomial distribution, and we can use this little law here for more complex problems. So now we want 2 heads and a tail from 3 tosses, and this is where this law is going to come very handy, because we want the probability of 2 heads and a tail in no particular order whatsoever. So you can just go ahead and you can go, right, we want to choose from 3, we're choosing 2 heads, and then the other one must be a tail. So the probability of a head is P, and that's to the power 2, and then 1 minus P to the power 1. So that's, when you clear it up, is going to give you 3P squared, 1 minus P. Another way you could have thought about it was just the probability of a head, and a tail, the probability of a head, a tail, and a head, and then the probability of a tail, head, head. And that would have just been the same as P times 1 minus P, P times 1 minus P times P, and then 1 minus P times P times P, and then we just add them together and we get 3P 1 minus P, 3P squared, 1 minus P, which is our result here. Okay, so question B asks us to relate the things we've just found in AI and AII. So we had the probability of head was equal to P cubed, and the probability of 2 heads and a tail in no particular order was 3P squared 1 minus P. So if the probability of obtaining 3 heads is equal to the probability of obtaining 2 heads and a tail, find P. So that just lets us equal these two together. So we get that P cubed equals 3P squared 1 minus P. So at this point, let's bring it all over to one side of the equation. So we're going to have P cubed minus 3P squared 1 minus P equals 0. Now let's factorize P squared out the front. So we're going to have P Actually, first off, we might just expand this out. So here and here. So we're going to get p cubed minus 3p squared plus 3p cubed equals 0, which is the same as 4p cubed minus 3p squared equals 0. And now we'll factorize that p squared out the front. We get p squared outside of 4p minus 3 equals 0. So according to the null factor law, we could have p squared equals 0, or we could have 4p minus 3 equals 0. So this implies that p equals 0. That would work. And this one implies that 4p equals 3, therefore p equals 3/4. So the trick for this question is to not assume that the probability can't be 0. Because we had the word bias in the question, p equals 0 is possible.